that topic. Now you're going to do that topic on your own.
Okay.
You see functions and graph, but you're not only going to do like self study. I've already have videos on functions and graph now. So
Okay.
I'll give you the links to work on the platform on YouTube. Go through that course on function and graph. Everything that you need, it will be on that. But I'll do some of the questions with you. Don't worry. So we'll cover this too. But today, I want us to focus on that analytical geometry. We already did trigonometry. We're done with trigonometry, but we'll do reinforcement. Okay.
Okay.
Right, we'll do reinforcement on trigonometry, and then when I look at Euclidean, this one we need to do more work on Euclidean, but let's try and make sure that today, even during the week, we finish with analytical geometry, okay?
Okay.
Right, and this will be one of the easiest topic you'll see. Analytical geometry, it's very, very easy. So do you have any question?
No, sir, but this Friday we are this Friday we're writing a
You said
test
physics, right?
on no math
Maths on
for
what?
yes,
On?
just math. Paper 2, everything for paper 2.
Okay, don't worry. This is what we are currently working on now, right? So do you have the topics for paper two, or they'll be the same for this one, for the June exam one?
Uh sorry, didn't um trigonometry, Euclidean, and analytical
Okay,
geometry.
okay. So are you going to be available Monday? We're going to have a session again tomorrow. And if possible, we can have a session in the morning. You're not available in the morning tomorrow.
No, no. When in the morning, sir?
Like around 9:10.
No, sir. I'm at church.
Okay, it's fine. We'll do later, né?
Okay.
Okay, so now looking at this, we'll focus on analytical geometry. So now on analytical geometry, there are some of the things that we'll go through, but tomorrow we'll start with the properties of quadrilaterals. I'll send you notes on properties of quadrilaterals, and I want you to go through those notes, okay?
Okay.
Right. So the most important thing with analytical geometry is for you to understand the formulae that we're going to use on analytical geometry. So this will be the formulae for that we use on analytical geometry. Can you see my screen?
Yes.
Okay. So, okay, let me do this. Okay. Okay, so now let's start with the first one, which is something that you will need to understand. It has to do with the distance. So this one is the distance, okay? That's the formula for distance. So the formula for distance, we're going to use this to calculate the distance between 2 points. So in order for you to calculate the distance, you need to have 2 points. Right? So let's say that we have point A and point B. So if this is point A and the coordinates of A is X, and then point A, let's say point A will have X1 and, okay, let me write this down. This will be X1, Y1. And then point B will have the coordinates X2 and Y2. Look at this. A comes first. I'll always name the point that comes first as X1, Y1. And then the one that comes after that one, I will call it X2, Y2. So the distance is X2, you minus X1, close the bracket, squared, plus into Y2 minus Y1, close the bracket, squared. Is it for the first time you see this formula?
No.
Okay. So this is the first formula that you need to understand, the distance formula. The second formula is what we call the gradient. Okay, so the gradient is the change in y over the change in x. So when they ask you to find the gradient of AB, so I'm going to say the gradient is denoted by m, and then from A to B, it will be the change in y. So the change in y is going to be y2 minus y1, and everything is divided by x2 minus x1. Right. So this is the formula that we'll use to find the gradient. And then now let's talk about the midpoint. The midpoint. Before we go to the midpoint, let's go back to the gradient formula. Why do you need gradient of the certain line? So now if I want the equation of the line AB, it should be in the form of m, which is the gradient of that AB. This gradient should be multiplied by x and then plus c. So you need the gradient of AB to find the equation of AB. So if your gradient is wrong, the equation of AB will also be wrong, which makes other upcoming questions to be wrong. So it's very important that you don't make mistakes when you do your substitution. The midpoint formula, if I have two lines like this, and this is A, this is B. So the line, when I say this is point C, and then I tell you that this line AC, it's equal to that line CB or BC. This tells you that C is a midpoint. So this C is the midpoint. Right. So if C is the midpoint, we need to find the coordinates of C. And the formula that we're going to use to calculate the midpoint is going to be x2. You're going to add the x coordinates of A and B. You add the x coordinates, the answer that you get, you divide by 2. And then same applies for the y coordinate. You add the y coordinate of A and B. The answer that you get, you need to divide that answer by 2. Right. So that is the midpoint. That is the formula for midpoint. Then the next one, the equation of a straight line. So in an exam, they'll ask you to find the equation of a straight line. Right. Do you know the standard form of the equation of a straight line?
No.
Okay. Or the standard form of the equation of straight line, it's in the form of y is equals to mx plus c. Is it for the first time you see this?
Yes.
Okay, so you see this equation, it plays a very important role in functions. It plays a very important role in analytical geometry. The most important thing that you need to understand is that m is the gradient. And we said the formula for the gradient is the change in y over the change in x. Okay, that's the gradient. This c is going to be your y-intercept. Right, it's where the graph cuts the y-intercept. You understand?
Yes.
Okay, so now that you understand the equation of a straight line, we have something that we call parallel lines and perpendicular lines and collinear points. But let's start with the parallel lines. So if I tell you that, if I say I have lines that are parallel, let's say we have lines that are parallel, this will be parallel lines. What do you know about the gradient of parallel lines? What do you know?
That if there's another parallel line, then they have the same gradient.
Exactly. So the parallel lines, the gradient of the same line, it will be equals to the gradient of the second one. And then for perpendicular lines, this one, for perpendicular lines, this one will be the gradient of the first line, you multiply with the gradient of the second line. They should give us the product of minus 1. So the product of these two, it's 1. So I'm going to give you a tip, which is an exam tip. Why am I giving you this tip? I need you to save time when you are in an exam. Né?
Okay.
Okay, exam tip. When you are in an exam, I need you to tip and change gradient. Né? To tip
Okay.
and change gradient. So I'm going to show you how this works. Let's say that the gradient of the first line, let's say it's minus 3 over 4. Therefore, the gradient of the second line, you just take this, you interchange, and then you write it as what? You change the sign into positive, then you write this as 4 over 3. You understand? You write the reciprocal, because if you multiply these two terms, we need to get the gradient as minus 1.
Every single time.
Yes.
Oh, okay.
So now you'll see when we do examples. Now, don't worry. So what I'm trying to say is that if you have the gradient of the same line and they tell you that the line is parallel to that one, just know that the gradient of the second one is 4 over 3. But if you prefer to use the formula, let me show you how this works. So the gradient of the first one, it's minus 3 over 4, right? We multiply this by the gradient of the second one, we should get an answer of minus 1. So the aim now is to make m two subject of the formula. I'm just going to divide this side by minus 3 over 4 and then divide this side by minus 3 over 4. So this cancels. I'm left with m2 to be equals to. So the gradient is like saying I have minus 1 over 1. Then we are dividing by minus 3 over 4. So this can also be written as minus 1 over 1. We multiply, then you interchange. This is 4 over 3, but it's negative. Therefore, it's like saying negative 1 times minus 4 over 3 is just 4 over 3. That's it. Or you can just, from this point here, you can just punch a calculator from this point here, put this on the calculator, you'll find that the gradient of the second one is just 4 over 3. But now, to save time, I don't want you to do all these calculations. Né? I want you to tip and change the gradient to find the gradient of the second one. Are you with me?
Yes.
Okay, let's do an example. Let's say that the gradient of the first one is 2. What will be the gradient of the second one if these two lines are parallel?
Negative 3 over 4.
Listen, the first gradient is 2.
Oh.
What will be the gradient of the second one?
2 over 1.
Exactly. But now, no. Listen, that's not correct. Listen. Look at what we did here, okay? We have minus 3 over 4, right?
Yes.
And then we equated this to 4 over 3. So the first gradient will have minus 3 over 4. This tells you that the second one, it will be we interchange this with a different sign. So if this is 2, we know that any number is over 1. Then what will be the gradient of the second one?
Negative 1 over 2.
Exactly, negative 1 over 2. Because if I put the 1 here, now I make everything to be easy for you, you see?
Yes.
So now, if the gradient of the first one, let's say, is minus 1 over 2, what will be the gradient of the second one?
2 over 1.
Which is just 2. Thank you very much. Now we can move. Ne? Are you happy about that?
Yes.
100%. So now, I want us to talk about collinear points, okay? So the collinear points, you see this guy, ne? The collinear points, if let's say I give you 3 points like this. This is point A, this is point B, and this is point C. Can you see that all these points are on a straight line, same straight line?
Yes.
So the collinear points, if you can draw a straight line through A and B and C, the gradient are the same. So collinear points have same gradient. You'll see why it's important for you to understand this. So the gradient of AB is equals to the gradient of BC, which is also equals to the gradient of that AC. Okay, you'll understand how this works. Can we work on examples now?
Yes.
Okay. Let's say that I have a Cartesian plane like this. Okay, so this is your X, this is your Y. And then on the Cartesian plane, let's say I have a point somewhere here, and the coordinates of this point B are given as -2. Let me write it like this. We have B, and the coordinate of B is -2 and 1. And then this goes in that direction all the way to point A. The coordinate of point A is 6 and 5. And this goes to this point here. And the coordinates of this one, let's say this is C, which has the coordinates 0 and -2. So this is given. And now let's answer the following question. Okay, let's say the first question, number 1. Find the gradient of AB. Find the gradient of AB. So I'm going to give you maybe 2 minutes to work on this. 1 minute. Look at
Okay.
AB, do the substitution and find the gradient, okay? And tell me
Okay.
what you get. Okay, I'm listening. What's your answer?
1/2.
You got 1/2.
Yes.
Okay, let's quickly verify that. Remember, we are given AB. I'm going to first, listen, I need you to also follow the steps in an exam. You need to
Okay.
say A, you write your A down. The coordinate of A is 6 and 5. And then B, the coordinate of B, that's -2 and 1. So between A and B, we know that alphabetically, we're going to say A comes first. This is my X1, Y1, and this will be my second point. Are you happy with that?
Yes.
Then you're going to write down the formula of that gradient. We know that the gradient formula, the gradient of AB, is equals to the change in Y over the change in X. Then I do my substitution. So now you don't have to stress, because already you know what is your Y2. It's 1 minus Y1, which is 5. Everything is divided by X2, it's -2, then minus X1, which is 6. So this gives us the top part to be -4, the bottom part to be -8. And when you pass that on the calculator, it's 1/2. Thank you very much. So 1/2 is the gradient of AB. So now the gradient of AB, it's equals to 1/2. Let's move to the next question. Thank you very much. You did very well on that one.
Thank you, sir.
Nice. Let's find, we're going to do this one together. We're going to find the gradient of BC. We're going to find the gradient of BC. Remember to follow the steps. First thing first, you write down those coordinates of BC. So B, my points B will be -2 and 1. And the point of C It's given as 0 and minus 2. Then when you're done, you name your points. Which one comes first? Even if you name this as your first point, it's fine, but I always like to put my house in order. So this will be x1, y1, and this will be x2, y2. Why are we naming these points? Because we don't want to do substitution, the wrong substitution. Therefore, the gradient formula, it says that the gradient, okay, let me just write it down here. Therefore, the gradient of BC, it will be the change in Y over the change in X. Right, let's do the substitution. Tell me, what is your Y2?
-2.
-2 minus what is your Y1?
1.
1. Everything is divided by. What is your X2?
0.
Then we minus, what is
2.
your X2? Your X1?
Oh, put it in brackets. So then,
Exactly. We need to put that in brackets so that the negatives can cancel. So the top part, what do we get on the top part? -3, right?
yes.
So the top part gives us -3. The bottom part gives us +2. So the gradient is just -3 over 2. So this is the gradient of AB. Okay, are you happy with that?
Yes.
Let's answer question number 3. The question number 3 is asking, is the line AB perpendicular this? This thing means perpendicular. Is the line AB perpendicular to BC? What will be your answer for this one? Are the two lines perpendicular?
Yes. No.
Okay.
Yes.
Yes, no, which one are you going to go with? Please don't do guesswork because we're going to need a reason.
I think so.
Why are they perpendicular? Why do you think? Remember, when we go back to what we've discussed, we said that two lines are perpendicular if when you multiply the two
Oh.
gradients, you get an answer of -1. When you multiply the gradient of AB with the gradient of BC, do we get, I think we made a mistake here, we're supposed to say BC. So when we multiply the gradient of AB and BC, do you get -1? AB, it's 1 over 2. BC, it's -3 over 2. So when you multiply the two, do you get your answers -1?
No.
No. So now, if your answer is no, first thing first, you're going to do what we call check. You're going to check, and this is how you check. The gradient of the first one multiplied by the gradient of the second one. Please don't say it's equal to 1 -1 because we're not sure yet. So the gradient of the first one, it's 1 over 2, which we multiply by the gradient of the second one is -3 over 2. So when you punch that on the calculator, you get that the product of these two gradients is -3 over 4. So therefore, -3 over 4 is not equal to -1. So since they are not equal, AB is not perpendicular to BC. Then what is the reason? Because the product of the two gradients does not give us what we are looking for. So because the gradient of the first one multiplied by the gradient of the second one is not -1. That's the reason. Okay?
Yes.
100%. Let's move to the next question because there are many questions that you can get from this diagram. Okay? So the next question, let's say they ask you to find the length of BC. Find the length of BC. I'm going to. I think you understand what is going on now. Always write down the coordinates of B, and we know that the coordinates of B we said it's -2 and 1, and the coordinates of C it's 0 and -2. Name which one is your x1, which one is your x2. You don't have to be like lazy when it comes to these things, because one mistake you do wrong substitution.
Yes.
Right. I'm going to write down the formula for the length, and we said that the BC, which is the distance, it will be the root of x2 minus x1 squared. We add y2 minus y1, and this is squared. Therefore, BC is equals to, what is your x2? It's 0 minus x1. So now look at that x1. It should go inside the bracket, né?
Yes.
So it's 0 minus into minus 2, close the brackets, squared, plus y2, which is -2, minus y1, which is 1. I need you to assist me with the calculator. What do you get when you punch that on the calculator? What do you get without the square root? So this will be BC equal to the root of, work the inside first, inside the bracket first. Tell me what you get.
Sorry, sir.
What do you get when you punch what's inside that bracket? Remember, this is the same.
-4.
Remember, this is going to be -2. Is like saying this is 2 squared plus -3 squared. And 2 squared, that's 4, okay? And then plus 9, that's 13. So this will be the root of 13. It's equals to BC. But now, you'll follow the instruction. If they want into decimal place, you have to punch SD on your calculator to put it into decimal place, okay?
Yes.
Okay, so now, let's find the midpoint of AC. Let's go to the diagram and look at where is AC. So if this is my AC, we are looking for the midpoint of that line. You still remember the formula, right?
Yes.
Okay.
Yes.
Okay. Even when I'm looking for AC, I'll first write the coordinates of A down. We said it's 6 and 5. Okay, 6 and 5. These are my coordinates, 6 and 5. And then the coordinates of C is just 0 and -2. Let me name my points. Which one is my x1, y1, and which one is my second point. Then I'm going to write down the midpoint formula, and we'll take it from there with the substitution. So the midpoint is x. We add the x coordinates. The answer that we get, we divide by 2. And this side, we add the y coordinates. The answer that we get, we divide by 2. Putting this on the calculator, the top part is x1 plus x2 divided by 2. Then y1, which is 5, plus y2, which is -2, divided by 2, which is the same as 5 minus 2. So this one, it will be the midpoint of, if you can just put that on a calculator, 6 over 2, which is just 3. Therefore, 5 minus 2, that's 3. 3 divided by 2, that's like 3 over 2. So the midpoint is 3 and 3 over 2. The 3 over 2, you can write that as your uh, decimal form and say the midpoint formula is the same as 3 is to 1.5. All good. Are you happy about that?
Yes.
100%. Okay. So now that you understand these things, how these things work, uh, just give me a second. Let me see how much time we have. Because, okay, we still have time. Just give me a second. Okay, so now that you understand how this works, let's work on this past paper. So if I look at this question 2 of the grade 10 past paper, so they say in the diagram below, most case, you'll see that whatever that you have on the statement, it's what it's on the diagram. They're just telling you about the diagram. So now I'm going to look at this question. Let's try and answer the following question. Determine the coordinates of T. That's 2.1.1 for 2 marks. Look at T. So you know what you need to do. You go to the statement and you need to understand what are they saying about T on the statement. Can you please read that part?
In the diagram below, T is a point on PQ that such that T is the midpoint of PQ.
And
So
already you know how to find the midpoint, right?
yes.
So T is the midpoint, and to find the midpoint, we need the two coordinates is the midpoint of PQ between P. So if I write my coordinates like this and say this is my P, I'll have P as 1 and 0. Then I'll have Q as 6 and 3. Okay, so now when I look at this, what is my x1? This will be my x1, y1. This will be my x2, y2. Then I'm going to find the midpoint. I know that to find t, I'll use the formula that says t, the coordinates of t will be uh,
X1 plus
x,
X2.
okay, x1 plus x2, we divide that by 2, right?
Yes.
And then
Y1 plus Y2.
exactly. So now
Okay.
look at this now. I need you to put that on your answer sheet. They need to see the formula. Most sometimes they might give you a mark for that formula.
Okay.
So when we substitute, this will be t into x1, it's 1, plus x2, which is 6. Divide the answer by 2. Then we look at y2 and y1. So it's 0 plus 3. Divide the answer by 2. So now what do I get? What is t? So t is the same as 1 plus 6, that's 7.
Yes.
So if it's 7, the coordinates of t will
Is
be
7/2.
exactly 7 over 2 and what? 3 over 2.
Yes.
Those are the coordinates of t. Right. I know that we did not yet talk about the equation, but now it's your best chance to find this. They want us to find the equation of QR. QR, the length QR, we need to find the equation of that QR. And remember, we said that the equation, it should be in the form of y is equals to mx plus c. Do you still remember what is m?
M is the gradient.
Let's first find the gradient of that line of QR. Thank you very much. That's very correct. So the gradient of QR, I'm going to say y2 minus y1. The answer that I get, I divide by x2 minus x1. So I need to write down my points, name my points, and then we'll take it from there. So if this is Q, it has the coordinate 6 and 3. So I think Q comes first, né? Or is it
Yes.
RQ? QR. Which one comes
No,
first?
P come, huh? No, Q.
It's
QR. Yes, Q comes first.
Q comes first.
Yes.
Okay. Then R is going to be 9 and minus 2. Even if you don't go with which one comes first, it's fine as long as your substitution is right. So this will be my x1, y1. You know why I always like to put them as like they come first? Like I feel bad when I say A, B, and then I name B as x1 and y1 is in like A, B was born first. I just feel so bad, you understand? Even though I'm going to get the correct answer.
Yes.
So x2, y2, then uh, then I'm going to say this will be the gradient of QR will be y2, which is minus 2, with minus y1, which is 3. Everything is divided by x2, which is 9, minus x1, which is 6. So the top part gives us minus 5, and the bottom part gives us what? Uh,
3.
3. So this tells me that the gradient of QR is just minus 5 over 3. Right. So this makes sense, ne? I'm going
Yes.
to explain why, ne? If you have something like this, ne? If the gradient of a straight line is positive, your line will look like this. And if the gradient of a straight line is less than 0, your line will look like this. Look at this line. I think you can see that the line shows that this is a decreasing function. So the gradient is negative. So now
Yes.
that we have the gradient, what's next? We said that this should be in which form? This should be in the form of y is equal to mx plus c. So this is in the form of y is equal to mx plus c. But already we have the gradient, so this will be y is equals to minus 5 over 3x plus c. The only thing that you need to do is to find c. Do you have an idea how we can find c?
No.
Okay, so to find c, you can choose either points on that line and then substitute on that equation and solve for c.
Mm,
Do you understand what I'm saying? Look at
no.
this. I have
Okay.
y, it's equals to minus 5 over 3x plus c. And this
Oh.
is the equation of what? This is the equation of QR. I can choose Q, I can choose R. Any point that you choose, let's say I go with Q. Any point that you choose, you'll still get the correct answer, which is 6 and 3. So when it's like this, I'm going to name my x. This is my x. This is my y. So on the equation where there's y, you put 3. And where there's x, we put 6 plus c. Then what is minus 3? Oh, what is minus 5 over 3 times 6?
-10.
Okay, so this is 3. It's equal to negative 10, right?
Yes.
The 10 comes this side to be positive. This gives us c to be 3 plus 10, that's 13. So the value of c is 13. If the value of c is 13, this tells you that the equation of the line is y is equals to minus 5 over 3x plus 13. So now, this makes sense because look at where's this? We know that this is not drawn to scale. But I know that the y-intercept, it will be positive y. Because you see this line will keep going up until it reaches a positive y-axis. Until it cuts the positive y-axis. You understand?
Yes.
Are you happy with how we answered the question?
Yes.
Right. This, it looks like a long method, but it's not. We need that 3 marks, ne?
Yes.
Look at this. We just did 2.2 now, and you get it in an exam like this. If you still remember, on 2.2, we did something like uh, is AB perpendicular to BC? So this time they change the question and ask you, prove that PQ and QR are perpendicular. I think you know what you have to do on that one.
Mm, still solve for perpen. Still solve using the perpendicular equation.
Exactly. But first thing first, look at this. You need to find the gradient of PQ and the gradient of QR. But each and every time you do something, go back to the previous question and check if you don't have one of these. Look at this. Already we know the gradient of QR. So the gradient of QR, we calculated that, and what was the gradient? So to save time, I'm not going to calculate this two times. So it's minus 5 over 3. So the gradient of QR is minus 5 over 3. The aim now is to find the gradient of PQ. So the coordinates of P, what is the coordinate of P? It's 1 and 0. And then what is the coordinate of, okay, it's 1 and 0. And what is the coordinate of, it's PR. What is the coordinate of Q? Q is 6 and 3. So I'm going to put 6 and 3 there. So now the next thing, when I calculated this, I need to find the gradient to be minus 5 over 3. Say, oh, not yet. Not minus 5 over 3. So this is my x1, y1. This is my x2, y2. So this one, when I keep on working on that, let me see what I get. The gradient of PQ, it's equals to y2 minus y1 over x2 minus x1. And what is that giving us? So y2, that's 3, minus y1, that's 0, over 6 minus 1. Therefore, this gives us 3 over
Over
5.
5.
You see, this proves something that I told you in the exam, that not in the exam. When we started the lesson, I said, if two lines are perpendicular, the gradient of this one, to find the gradient of the next one, you just interchange that, you write it without a negatives. Look at our answer, 3 over 5, which is the reciprocal of 5 over 3 with a different sign. So therefore, these two are perpendicular, because if we take the gradient of the first one, multiply by the gradient of the second one, we get minus 1, okay? You understand?
Yes.
Okay. I'll see you. I just have to rush for the grade 12. Please give
Okay.
me this 5 minutes. So I'm just going to steal 5 minutes from your lesson. Look at
Okay.
this. The length of PQ, you know how to find the length. You just do the substitution. Easy marks. The
Yes.
area, on next one, we're going to talk about the area and the properties of quadrilaterals. That's what we're going
Okay.
to do next time.
Okay. Thank you, sir.
Thank you very much for attending. Please have a great day and just keep moving and studying. I'll see you tomorrow.
Okay. Thank you, sir. Have a wonderful evening.
Thank you. Sharp, sharp.